34 years of Monad tutorials. Has anyone learned anything? This is going to be pretty different to the usual talks at the Brisbane Functional Programming Group. Did this on the 10th of March 2026. This is going to be an anthropological study. So we're not going to simply try to declare what the best Monad tutorial is. We're going to look at the entire corpus of 34 years of Monad tutorials and, look at strategies and all of that from an anthropological lens. So people who come towards a language like Haskell naturally ask, why are there so many of these tutorials? It's obviously a pain point for beginners who are trying to learn. The Haskell wiki itself has got a page just on Monad tutorials, and yeah, there are a lot. It sort of leveled off around 2025 because I think people got sick of this topic itself, and I think there's also a lot of activity in other languages looking at monads. So it's an interesting corpus, and so I thought, why not take that list of tutorials, do a few searches for some of the recent years just to see if there's things that have been published that haven't been added to that wiki, and that provides a nice chunk of about 34 years, about 500,000 words, and we can use that to do an analysis. So it's a significant chunk of text to look at and work out how people write things. We have 8 rhetorical moves that I believe every Monad tutorial has to make. And from anthropology, we can look at rites of passage, recursive publics, and boundary objects, which are different ways to look at the entire concept of these tutorials. And the sort of classical nerd expression is that you'd say tutorial proliferation is a feature, not a bug. I would say that it's more of an emergent property of people trying to solve difficult things and learn together. So what's the corpus? It's just the posts on the Haskell wiki. It's about 500,000 words. I added a few extras. It's almost entirely HTML because these are almost entirely blog posts. The 1992 one from Modeler is a PDF. So I've not tried to do an exhaustive search here. I'm ignoring lecture notes and books and that sort of thing. It's really just the Haskell wiki plus a little bit of extra stuff to capture the last few years. And again, this is just rough, like a rough prototype. That's an approximate count across the years. There was a decent peak in sort of 2010 to 2016. I think that's where a lot of the real activity happened. The later activity, I believe, is from people looking at the concept from other languages like Kotlin or JavaScript or other things. And so the titles alone show an evolution over time, starting with Monads for Functional Programming, ending with the ultimate and final Monad tutorial you'll ever read. So that's from 1992 to 2024. And in between you see a proliferation of things like monads and spacesuits. So that's the analogy genre within the Monad tutorial genre. There's people trying to do the tower of things like functors, applicatives, and monads in pictures. You get all this burrito stuff. 2023, I guess there was an appeal to our future AI overlords, so monads according to a robot. Yeah, so there's a huge range of approaches. Why are there so many? What is everyone trying to do? And basically there is this concept of a rhetorical move. So John Swales did research on analysing academic writing, and he talks about a move, which is a strategic communicative choice. So in his field, every research paper, like an academic paper, has to has to do the same thing. It has to talk about the territory, establish a niche in that territory, and then occupy that territory. And Monad tutorials are doing basically the same thing, but the choices obviously vary dramatically, as you can see just from the titles alone, and so that variation tells us about the community itself. So we can look at the whole community by looking at how these different tutorials are being written. So again, just using a frontier model, a quick stab at the 500,000 words, and I think there's about 8 rhetorical moves that we have. Some of these obligatory just means that you have them in all of the tutorials that we look at. M3 for reference tutorial tradition is like one aspect of self-awareness that was rare in the past and grew over time. There's a sort of higher level self-awareness about the entire problem of these Mono tutorials. There's basic things like selecting the explanatory strategy, talking about who the author is, and establishing professional context. There's a choice that you can make. It's a bit of a Boolean, like, do we deploy an analogy or not? Personally, I'm not a fan of the analogy style tutorials because I think they distract you from what you're trying to actually do. And there's a little chunk M8 is just distinctive features, weird things. So this is a rough first stab at working out the different strategies. I think it covers it pretty well. I'd be happy to hear if there's another dimension that I've missed. And so the first one of interest is, how do the authors position themselves? And almost all of them are demystifiers. I mean, that's not so surprising. Like, you want to say, I'm going to show you how these things work, and after you read my little tutorial, everything will be fantastic and clear and no problems. Other people try to say, I'm the big expert and I can explain to you, the little baby Haskell person, how to do this. You've got neutral explainers. That's kind of my preferred style. I think that you don't assume too much about the person and try to just walk through the problem calmly and neutrally, and I think that sort of accepts the wider range of people because you're not pigeonholing who your reader is. There's the fellow learner thing where someone has gone through the agony, they've learned it themselves, and then they try to forget that, pretend that they're a learner, and move through it. And you have the sort of meta level stuff where they're talking about the thing itself, kind of like this talk is being a meta level analyst. So the primary strategy, again, this is a rough analysis using a few Python scripts and some frontier model. Mixed just means that there's a couple of the things below. A lot of tutorials will unintentionally take on different strategies. But yeah, the most common singular sort of strategy is type-driven. So you sit down with the Haskell types, you reason through what type class should be, you try to do things from the types, which is, I mean, not surprising given that it's Haskell. You can try to use analogies. Again, I'm not a fan. I think they're a waste of time. You can go meta level. You can do problem discovery where you sit down with an evaluator, like an expression evaluator, and you work out that you need to have state attached, and it's terrible if you have to pass the state everywhere, so maybe there should be a state monad, and you show how you can discover the state monad yourself. There's engineering approaches where I guess that's also my kind of preferred style of does writing the code in a language without a monad make things too complicated? Does it solve an actual engineering problem? Does it actually help you create bigger systems that are more reliable? You can go full category theory. They ultimately own this concept, so I mean that's really the true goal, I guess. You can also try to do examples first and have people see the pattern and suddenly generalize up. And there's very few, but there's some visual. And again, personally, the visual style doesn't really appeal to me. I think in more abstract terms. And these different philosophies kind of cluster together in three pretty distinct styles. You've got the formalists who are, I guess, aspiring to the academic style of things. So you're going to use the types to drive the strategy. You will define things in the foreground. There's no analogies or very few analogies, and it's obviously expert positioning. You have the storyteller who likes to avoid the definition as far as they can because you want to get to that at the end, and they are demystifying, so they're trying to help the student. The formalist might be just declaring what it is, and it's up to you to go and have your moment of insight yourself. And the guide is the fellow learner position, basically, who Doesn't want analogies because we prefer examples and problem discovery, and we will get to the definition and construct it at the end of our little journey together. So that was the three main clusters. Another kind of group that turns up is the metaphor zoo or the analogy zoo. This seems to have started back in 2005 with a post about spacesuits. Personally, I really don't click with any of these, except for the programmable semicolon one. I think that's really cool. The original paper on STM just shows you examples that you could never implement in another language like Go or Python. And if your problem space had a very complicated thing that was clear to do in STM and not clear in Go or Python, you could argue that that's a better place to be. So I won't say any more about metaphors or the analogy controversy, but the proliferation of these did give rise to what seems to be an inflection point in the genre's evolution. That was a post by Georgie, I hope I pronounced that correctly, who said that, we have this problem that someone tries to learn about this topic, they struggle for a week, they have an aha moment where it clicks, and then they write one of these tutorials. And that's well-intentioned, but it has a mistaken assumption that if you simply read one of these aha moment tutorials, that you're going to magically get the aha moment yourself. And the problem, as down the bottom there, is that you need to do the work to actually get the insight. And this is the same with maths or physics or any super technical sort of field. I think Richard Feynman used to say that when he was reviewing a result, he would read the introduction and then try to derive the result himself and then look at the paper. So that's like an example of doing the work. It's unavoidable. Without doing the work, you just don't get to the thing. So this is basic pedagogy, I'd say. But before 2009, there was just the basic competition on my explanation is best. There were analogies proliferating all over the place. No one was really discussing the genre itself. After this, we have things like explicit anti-analogies, purely verbal things, and tutorials should have tried to justify why they were doing what they were doing. So it's definitely a point. I wouldn't argue that this is like the thing that caused the entire shift. I mean, it might have been building over time, but it was definitely a clear, an inflection point. So that's one way to look at this whole space. Another way is to lean on anthropology. So they've got theoretical lenses to look at a community. So one lens is the rite of passage, where we would say that writing a Mono tutorial is an initiatory act. There's a recursive public. I'm sort of less strong about this one. And the boundary object, which I think is actually pretty interesting. So the rite of passage is where you start not understanding and you have outsider status. So this leans on the concept of identity, which is basically everything. You have liminality, which is the in-between struggling. And after you've done that struggle, it clicks and you write your tutorial. And so the tutorial itself that's produced is not literally a teaching thing for someone to read. It's a ritual enactment of having crossed the threshold. So you get to say, I am a fancy Haskell person because I have a blog and I wrote my own tutorial, so I must understand. So it's moving from outsider to insider status. I think that's fairly reasonable. The Mono tutorial fallacy post, I think, is evidence for this interpretation, but I mean, I'm open to suggestions here. The recursive public is maybe less strong. The idea there is that the community reproduces itself through tutorials about the concept of defined membership. And I've admittedly taken part in this weird self-referential loop. I think on my own blog, I've got an article about free monads, and when I look at that, I see that I was riffing on David Lang's talk at BFPG in 2014. And so I spent time with this and popped out this thing about free monads that I've then not really looked at again and haven't really used. But so I've produced a thing that then someone else would look at, and then I followed, someone else's style. So it builds into this loop, which is a little startling to realize when I was putting these slides together. So I don't know if the community maintains this infrastructure through its own existence as such, but I think it's an emergent kind of property. The one that I like is the boundary object concept. So a monad basically means different things to different people. So the category theorists own this at the very top level. They've got their endo functor over the yada yada yada. You get the Haskell implementers who go, cool, I've got a type and a type class, and I can sequence effects or do, that sort of stuff. I've got pragmatic programmers who think I need to compose computations, I want to have programmable semicolons. You get JavaScript people who turn up and go, oh, is this like a promise that may be more general? And the other weird community is tutorial authors who find that this is a challenging concept, and so you can kind of flex by showing how good you are by writing tutorials about this difficult topic. And so the boundary object is sufficiently shared to coordinate, but sufficiently plastic to accommodate different interpretations. So each tutorial is like a translation layer for a different community. And I think this is just a pretty cool way to look at it. So you don't have to say that these are all incorrect interpretations. They are just valid they're valid views for different communities. When I did the talk, someone asked what are the actual boundary objects from the original paper. They talked about things like museum specimens. So a poor little butterfly that's been pinned onto a board is it's a taxonomy to a scientist, it's a funding story for the administrator, and it's a curiosity for an amateur collector or a, butterfly enthusiast. So that's three very different social worlds, but they're all kind of interested in the butterfly stuck to the wall. Medical records are another good one. So you have your patient chart with some data on it, and you then have different people who look at it, like doctors, nurses, insurance people, lawyers, and they all come to the same stuff, but it means a whole bunch of different things for them. So it brings them together. They don't, you're not going to force the lawyer to look at the chart in exactly the same way as a doctor, but it is a shared plastic kind of interpretation. So yeah, I think this one's pretty cool. I'm kind of pleased to learn about this idea. So I would conclude that the answer is not because monads are hard to explain. I'd say that it's because we're humans, we're trying to learn, and we inevitably will create these kinds of social structure things like rites of passage, recursive publics, and boundary objects. It's just a consequence of what we're doing. And so I think it's fine to write them. I think if you're reading them, you should be aware that these are the reasons why people do this. So you can choose which ones to read and better spend your time if you want. And because I'm in a talk about nano tutorials, I can't resist throwing my own sort of perspective on this. I guess I'd position myself as a demystifier. The most important aspect for me is no analogies. I don't think that helps. I won't actually construct the definition here because we don't need to torture people at the end of a talk like this. And self-awareness is very high because I'm doing it in a talk about the genre of nano tutorials. And I guess the style will be humour or jaded from industry experience. So famously, there's Greenspun's 10th rule that any sufficiently complicated C or Fortran program has a crappy implementation of half of Common Lisp in it. Greenspun didn't have rules 1 to 9, he just turned up with rule 10 because that's how you can do things. And so I'm going to propose my own rule and say Hamalainen's 10th rule is that any sufficiently complicated Go web application, like something that's generating HTML strings, is going to have a crappy implementation of half of the HTML monad in it. So here's an example. We have a pretty complicated dashboard. We have a user with a name, and there's a list of their roles that they have. So how would you produce this HTML? You could just say, cool, we have a type for the user, and why not just print the strings out? That's perfectly valid, and you can imagine how this will go off the rails pretty quickly when someone tries to modify this and they accidentally delete that line, or they make a mistake over there. It's obviously not a great representation of the data because the HTML has a tree shape to it, and we've switched over here, and now we've got a very vertical thing except for the list. So this is not a great representation for the problem space. If you were doing this, you would just make many mistakes. It's hard to read. It's just got a lot of noise. So what's a better way to do it? There's a library called Gomponents or Gomponents, and that switches it into what looks like a tree shape. And this immediately looks a lot better. The shape matches the HTML. You've got the head, the body, you've got, the user roles down in there. The weird thing that's happened though is that we've switched away from normal imperative Go code, and now we're writing everything into the arguments of a function. So a variadic function that can take an arbitrary number of elements. And it's interesting that you can't write a for loop down there for the map line. You have to use something from the components library to do the iteration. In the same way that if you had wanted to change that line to say something about the user based on some attribute of them, at this point here, you can't write an if statement because Go has got statements and expressions, and everything that goes into a function call has to be an expression. An if statement itself does not actually have a value. And so that's where we run up against an odd kind of different sort of, I can't remember the word for this. It's just not quite right. It's close. It looks good for this example, but if you try to generalize up, it gets a little difficult, and it just feels a bit odd if you try to do things after that. For reference, the HTML monad in Lucid 2, when you try to do this, output looks like this, and it's super clean. If I had to modify a large web page that was being generated with this, I think I'd feel confident. It's easy to move things around. It's easy to see the indentation. It's just a lot simpler, and I think I could write functions that do parts of the page and compose them and trust that I'm not producing a big pile of garbage that doesn't fit together properly. But this Go code does look pretty good. So we wonder, where does this go off the rails? And so the components library is having to implement things. So first they did if, and the problem with that was that whether or not this condition is true or false, when you call a function like that, you have to evaluate all of the arguments. And so if this thing referred to user.something.whatever and hit a nil, it would crash. And so they had to implement laziness by using basically a manual kind of thunk. And this is actually pretty cool that you can do this in Go. Like, Go has got almost some of the nice bits of Haskell in a sense. You've got closures like that. You've got interfaces that are almost type classes. It's kind of smooth. Like, if you're sick of the OO style, Go is pretty nice. But they had to do this. And so this had to be a different thing, not like the normal if, but an if whatever that means. And then you see the same patterns happening, that the language itself has got for loops, but you can't use them. You have to use a thing called map. And again, like another language where everything's an expression, you'd get to use any sort of expression syntax that you have. And things got to the point where they said, well, if you need something, you're going to have to use an IIFE, which is an immediately invoked function expression, which lets you step out of the expression space back into the imperative Go code space. So in Go, everything has to either be a new combinator or jumping out to an immediately invoked function expression. The maintainer of the library, so that's from the README, says, well, sorry, this is just an example of it. That parens down there is immediately evaluating the function expression that you have here. So you're able to then use things like if and else and for loops, and if you want to have fun, you could then be manipulating some global state. If you had to iterate through a bunch of things and count some number and then pass that number to somewhere else in your HTML generation, that's what you'd have to do. And the author has said, we're done. We're not adding more of these combinators. Just use one of these and step out. So it's pragmatic. I think it's fine for a lot of things. It depends how complicated you're going to push this. They had to, as I said before, basically reinvent laziness, and this turned up in a Git issue. I think this was done in a fork and then brought back in. So yeah, people ran into an issue where, want to conditionally render a node if some variable is not nil, and then you end up with panics. And it's a pretty long discussion. You can see that people are saying there's apparently a lazy approach somewhere else. They're talking about, this is kind of a curiosity. I'd say, well, what's actually going on here is that you've got people who desperately do want to have, people who do want to have language control flow and structure, and they can't get it, and so you have to jump out to the imperative Go code. So the problem space is dictating what people want to do and what they want to write, and it's not ever going to work because Go still has statements versus expressions. And so I'd say the moral of this story is that if your problem keeps pushing you in that direction and your users keep asking for it, then you've either got to draw the line like the author did and say, that's it, we're not adding anything else, or maybe go implement this bit in a language like Haskell that has actual monad things. It truly depends on, the actual cost of doing it. Like if you've only got one giant weird page with lots of weird values having to be passed forward, like in a full monad thing, maybe then you could just handle that. It really, truly depends on the actual cost. You have to think about, future refactorings and how much agony that would be and make a decision about it. Sometimes the answer might be use Go anyway, otherwise it might not be. And even like when I used to work at Standard Chartered, there was a similar HTML monad, I think. And I did something that would bring it closer to the Go code, which looks more like an applicative, because if you have a whole bunch of messy input data, like a large sort of tabular thing, you want to first clean it and compactify it and get it down to what you actually want to render, so that then the rendering code doesn't have to deal with nils or rather nothings and that kind of thing. So I'm almost arguing that like the full monad structure might be a bit outlandish if all we're really doing is generating simple HTML. But yeah, it's a thing to think about and make a decision. So someone did point out that the academic authors also talk about some weird analogies like bananas and other things. But otherwise, yeah, I had fun poking around with the data. It's pretty cool that we can get through really large corpuses very quickly using frontier models and ask it questions and find out how things evolved over time. I think it's just a lot of fun, and it's all verifiable as well. So cool. Thank you.